Hey everybody, Christian here, and today I'd like to show you the brand new automation platform Kestra I'm running in my HomeLab. The Kestra team reached out to me a while ago and asked me if I'd like to take a look at their new platform that allows you to automate, schedule and orchestrate your IT stack. And once I had a look at it, I just immediately thought, whoa, this is amazing. You can do so many things with this tool. It can run scripts, query APIs, deploy infrastructure, and it seamlessly integrates into all our favorite tools we already know, just like Terraform, Ansible, Python, Node.js, even PowerShell. It also supports any cloud providers and even AI technologies, so the possibilities to use this tool are endless. And because I absolutely fell in love with automating stuff in my HomeLab, I mean, come on, who likes to do things manually? I thought it's about time to show you how it works, so we will install the free and open source community edition of Kestra together, and of course go through some interesting use cases and examples to give you some inspiration on how you could use it to automate anything in your HomeLab. Thanks Kestra for supporting this video and making this comprehensive tutorial guide possible, and without further talking, let's take a look and start automating your HomeLab. Okay, first of all, let us take a closer look at the homepage Kestra.io. There you can get more information about this app, look up the official documentation, or find the link to the GitHub repository. So make sure to give this one a star. And I just want to highlight a couple of interesting features about this automation tool. So for example, that it has a declarative workflow creation. So that means that you just tell the tool what steps and actions it should perform on your IT stack. And then it takes care of executing those workflows in a scalable multi-tenant architecture that helps you to simplify deployments and speed up development tasks. It also has a very nice all-inclusive dashboard, so that means you can directly start creating those automation workflows from the UI. It has an embedded Visual Studio Code editor on board, so there are no additional tools required. You can code it all directly from the UI. And it also offers in-depth monitoring metrics about all those executions, logs, and so on. Kestra currently comes in two different versions, the free open source community edition that you can just run in your HomeLab, and that comes with most of the important core features of this platform, such as the orchestration engine, access to over 400 plugins, so you can easily integrate it into all your favorite tools in IT stacks. But they also have an enterprise version, so this is mostly interesting for companies that need multi-tenancy, high availability, single sign-on, audit logs for additional users, and so on. I'm personally just using the free and open source version in my HomeLab, and I believe this is totally sufficient for 99% of the use cases. Click on Get Started. This will take you to the GitHub repository where you can look up the source code, some great example workflows, and so on. By the way, if you're stuck with anything in Kestra or you're running into any problems, the open source version also includes a community support. So on the homepage, you will find a link to their Slack community. Just join there and reach out to the Kestra team. They have a very responsive community support, so just reach out to them and yeah, bother them with any questions you might have. Just don't tell these folks I've said it in the video. I'm pretty sure you can't wait to install and try it out in your own HomeLab, so let's do that and deploy the free and open source community edition of Kestra on one of my virtual Linux servers using Docker. By the way, if you want to deploy this on any other environment, just follow the installation guides on the official documentation. There you can find guides to install it on Docker, Kubernetes, any cloud providers, or even deploy it as a standalone server using a simple executable file. However, if you're following this channel for a longer time, you probably know that I love to deploy everything in Docker Compose, because I believe this is the most simple and easiest way to get started. So let's click on Docker Compose. There you will find all the instructions, and yeah, let's just simply follow this. Okay, let's open a new connection on one of my demo servers, and let's create another project directory called Kestra Demo 2. Here we can download the Docker Compose file from the documentation, so I'm just copying this command here. This will download the Compose file, and let's check this out. As you can see, this Docker Compose project deploys two containers. The first one is a Postgres SQL database, so this is needed for Kestra to store all the important data persistently. And the second one is the Kestra server itself. It's important to know that this Compose project deploys the Kestra latest -full image. Kestra has two variants of their Docker images, the full version or just the normal version. And the full version already contains all the Kestra plugins in their latest version. So that means if you want to include that into your Terraform or Ansible stack, you're gonna need to deploy the full image. It's also worth noting that this is only meant for development because it's running the root user. If you want to know how to run it without root user, you have to refer to the Kestra documentation. But I think for most of the HomeLab scenarios, it isn't too bad to run it as root. You also need to mount 3 different persistent volumes into the Kestra container. The first one is for the persistent data storage. The second is the Docker socket. So that is needed because when Kestra needs to execute a workflow using the Docker runner, it will spawn up a new temporary container to execute all the scripts and the workflows. And the third is for the temporary file storage for this runner process. If you scroll down, you can also customize one environment variable that contains all the Kestra configuration file. So for instance, if you want to connect this Kestra server to an external PostgreSQL database, you can just change the values in here, such as URL, username, and password. Or if you need a user authentication, you can also enable the basic auth in this configuration file. Just define your username and password to have a simple protection for the Kestra web UI. In this demonstration, I don't need it, so I just set this to false, so we don't need to authenticate to the Kestra UI, but just know if you need to protect this, you can also enable the basic auth in here. For this demonstration, I just leave it as it is. You can just use this file without any changes. So let's just execute a docker compose up-d command to start up the container in the background. Now it's pulling down the Kestra image, and this image is pretty large because it contains all the 400 plugins. It might take a few minutes until it's downloaded and started the container. Okay, perfect. So the Kestra server should be up and running. We can check it with the docker compose ps. As you can see, everything is up. Let's open a new browser window and type in the address of my server on port 8080. So this will take us to the Kestra dashboard. As you can see, there is no user authentication because I haven't enabled the basic auth. By the way, on my other demo server, I'm exposing this using the traffic reverse proxy so I get trusted TLS certificates. And I'm also protecting this with the identity provider Authentic that I've covered in my last video on YouTube. So if you want to know how to protect this web UI with trusted TLS certificates and user authentication that supports multi-factor support, check out my last video. I've put your link to this in the description down below. And before we start creating our first flow in Kestra, let me show you around a bit. So here on the left side, you find all the different menus, like come back to the dashboard, open the embedded VS Code editor, create and edit your flows, monitor the executions and logs. Blueprints we will also cover in a few minutes. And also in the administration tab, you can see all the triggers, the workers, and statistics about your installation. In the settings menu, you will find general stuff in here, like changing the language, switching the theme to light mode. Oh my god, so let us quickly switch that back to dark mode. It's much better now. But yeah, here you will find all those general settings like font, the default namespace, default log level, and anything you might want to change. Okay, so let's start creating our first flow so I can demonstrate how to work with this platform. They also have a guided tour to show you around, but let us walk through this together. To create our first automation logic in Kestra, let's go to the Flows tab. So this will give you a list of all the Kestra workflows that you have created. Because this is a fresh installation, there's nothing in here. So let's click on Create. And this will start with a very basic Hello World template that we can just use and customize to our needs. Before we do that, I also want to show you the different types of views in Kestra, because by default, it always opens the source view, which is just the source code of the declarative YAML-based language in Kestra that you can use to write your workflow logic, but you can also switch the view to the source and documentation, and depending on what exactly you selected in your source code, it will show you a different documentation page. So if you just selected the first section here, it will show you the basic introduction documentation, the flow properties, how to work with this tool, and give you some examples. You can just copy parts of it here and change it in the source code. Now, if you select the hello task and go back to the source and documentation, it will only show you the documentation for that selected element, which is really amazing and so useful. Then you don't have to open the documentation in a different browser window and so on. This is really, really nice. And I'm often using this to learn more about the different types of tasks that I'm writing and what are the properties details and so on. Now, in the Source and Topology tab, this shows you the execution logic in a graphical overview. And this can be very useful if you have multiple tasks created and you have layered specific tasks. And if you click on the Edit button, it also opens the Form view where you can see all the different properties of the selected element and just change the values in here. For example, this is from the type log, so it has an ID, it has a message that you can customize. By the way, this is also very useful for non-developers. So for example, if you are defining all the workflow logic in the source code, but somebody who has no idea of how the declarative YAML language works and so on, he can just use the form views to quickly change any values in here. So this is really amazing for collaborative work between non-developers and developers. I like this a lot. Okay, so as a first demonstration, I just want to orchestrate some Python scripting. So I think this is a very simple way to test the basic functionalities of Kestra and give you a better idea of how you can use this tool to define your own specific workflows for your HomeLab. Now, let's go back to the source view. So this is where we can just go in here and change all of those properties and elements in a simple way. So for example, I want to rename this workflow to Python test, so I can just change the value in here. Namespace is really useful to group specific workflows. So I'm just changing it to demo. Now the tasks are defined here in a list. If you want to add another task in here, you can just add it with a dash. Give it a different ID, hello2, and then change the type. You can see the editor of Kestra always has a syntax validation and IntelliSense built in, so this is really amazing. If you type in a colon after the type, it will give you a drop-down menu with all the different plugins that it supports. For example, if you want to do something with AWS or with Microsoft Azure, you will find those plugins in here. Ansible, Terraform, any databases, also the scripting languages. For example, if we need something for Python, we can just type in Python and it will only show plugins that have Python in their name. And there are two different types of Python plugins that you can use to execute Python scripts, the Python commands or the Python script. Now, while the Python commands will just execute a Python command on the shell, the Python script is what you can use for executing inline script, for example. So let's just hit enter, and now we can start defining the properties. Again, just switch to the source and documentation. It will show you some great examples for the Python script type. You can just copy parts of it, go back to the source view and add it here. You can read all the different properties, or you can just go and switch to the topology view. As you can see, now we have those two different tasks in the graphical overview, and we can just go here, delete the first one because I don't need it anymore. And I can edit the hello2, for example, change the name here to Python script, for example, and in this script field we can just start adding our Python commands. For example, let's do something very simple. Hello from Kestra, just print it to the console. Here you can also change the interpreter, for example, if you have a different program you want to use, and configure the runner. Now the runner you can change for specific task types. In this case, we can switch it to process, so that would mean when Kestra executes this Python script, you can define how it will orchestrate it. So should it just use a simple process that it should execute from the Kestra server on this machine or this instance where you're running the server process? Or should it create a new temporary Docker container that is using a Python image to execute those Python commands? So this is really useful if you have different types of automation scripts with different types of dependencies, and you want to make sure that it only has the libraries and pre-installed scripts that you want to define. So that's why I'm mostly using the Docker runner and spawn up a new temporary Docker container just for executing this Python script, and after that it gets deleted and it doesn't touch anything on the host OS. But as you can see, when you're changing anything in those different views, it respectively changes this everywhere, and it's really fast and quick to develop those automation workflows. Okay, so let's do a simple test. We will save this, and then once you have saved your first workflow, you can click on execute, confirm this, Now this will start a new temporary Docker container. We can see it in the logs later that executes our Python script. It will automatically launch the Gantt diagram that shows you how long it takes to execute this specific workflow. Now this can take a bit long because it first needs to create this Docker container, pull down the image, start up the new process and so on. If you have chosen the process runner, it would be a bit faster. If we click on that task, you can get the output of the console. As you can see, it pulled down the latest version of a Python image, started a new container instance and executed our Python script. It just printed hello from Kestra in the standard out log of the container. Because this is the first execution in this new instance, it might have taken a bit longer. If we now execute it again, it should be much faster. So now you can see it just took 3 seconds to create a new container and execute the Python command. In the logs, you can also get the detailed output. You can change the log level to debug, trace, info, error, or warning. And in the topology view, you can also see if you have different task types, so how long those specific tasks needed to be executed. You get a lot of great data and a lot of good overview of all the different automation logics and steps. And if we go back to the flows tab, you can see our new workflow in here, when it was executed the last time and what was the status. Okay, so this was just a very simple Python example to print hello world on the terminal. Of course, you might ask, so how do you use Kestra to do something useful with it? How do you find out what different types of plugins it supports and how you can use them together to actually do something meaningful in your IT stack? Now, what I definitely would recommend you to do first is you have to go to Blueprints. So this is like a template collection where you can find all different types of examples for Kestra. They also have a great overview about the different plugins on their homepage that you can use to find out what you can actually do with it. If you can script it, you can somehow program it in Kestra, and you even have the possibility to create your own custom plugins to add functionality to any application that has an API interface, which is mainly like everything in modern IT these days. So it's really amazing. But if you want to have some very specific examples, just go here. For example, if you want to automate an Ansible script with Kestra, you can just open the Ansible plugin, and this will give you an example. What is the specific type that you need to use if you want to execute an Ansible playbook, for example? So you just need to use this type here, how to input an inventory, how to input a basic playbook, and how to execute this playbook with a command in Kestra. And the same you can also do for something different. For example, Terraform. This shows you how to execute a Terraform file, for example. It also has a clone repository task in here, so you could define all the Terraform files for your entire deployment project somewhere in a Git repository, then clone this in the temporary runner process of Kestra, add the necessary variables like the secrets, and then just execute the Terraform init, the Terraform plan, and the Terraform apply command. If you have watched my video tutorials about Terraform, you will definitely know how to use this in Kestra as well. So this is how you can get up to speed very quickly. Just have a look at the blueprints, have a look at the examples, and just try it out yourself. Experiment a lot, because Kestra is like any other IT automation tool. It definitely takes some time to get up to speed with it and get to know all the different task types, and it will take some time for you to figure out how this all works together and how you can do something actually useful with it. Now, in the coming weeks, I will start developing some automation tasks in Kestra, and I will definitely make a follow-up video showing you what different automation workflows I have created. But I also thought it should be great to show you some fundamental things you just have to figure out in Kestra. How you can get different inputs in those workflows, how you can do things based on a status or based on a different output, do conditional things, and so on. For example, let's do a simple monitoring automation logic. So an automation workflow that will open a new HTTP connection to any website or to any portal, and based on the status code, if the status is different than 200, it will send me a message on my Discord. Hey, there's something wrong with this plugin, you have to take a look. So let's try to automate that in Kestra. I think that will be a lot of fun. Let's do that. In this script properties, we have our simple hello world command. Let's try to extend this. So if you want to add multiple lines in an inline script, you just have to type in a pipe, hit an enter, and then we can start adding our Python command. So if you want to send a new HTTP request in a Python script, if you're familiar with Python, you might know we need to add some libraries here. So for example, to create a web request, we want to import the request library, for example. And to make another web request to any website, I will store the response in a new variable, and the response will be the output of the requests.get, and then we can give it any URL. For example, let's start with something simple, google.com. Now, this response object will then contain all the output of this web request. It will contain the status code and the HTML response. Now, if we want to get this status code, we can just print it on the console by opening this object response dot and then simply status code. This will contain a 200 for OK, a 404 for not found, and something like that. Now, if we would try to execute this script in a new Docker container running Python, we will have to install the requirements for the request library, because usually by default it should not be installed. So this is why the Python script type in Kestra has a before commands attribute, where we can add multiple commands that should be executed before executing the actual script commands. So this is really useful for adding any pip install requirements. Here in this case, I just want to install the requests library. So we need to make sure when Kestra spawns a new temporary Docker container, it will first install the request library so it can be used by our Python script. Let's just save and test this. Let's click on execute and see if it works. So in the logs, we will see a 200 if the web request was done successfully. So that's totally fine. So that's great. Let's go back and edit our flow. Now I want to automate a Discord message. So depending on the status code, I want to send something to a Discord chat. And the cool thing is that Kestra already has a specific type for sending a Discord message using a webhook. So let's go and add another task in here that we just call Discord message. And as a type, we will type in Discord. It will show two different types, a Discord execution or a Discord incoming webhook. So this is exactly what we want to use. And if you don't know what type of properties this ID has, again, switch to the topology tab, click on edit, and it will show you all the different properties in a forms window. Or what we could also do is go back to the documentation. This will tell you some examples here. So maybe let's just copy this. I think this is a great example that we can use. So let's go back to the source window and let's add this in here. Now, this URL here contains the address of the Discord webhook, so we can just replace this by going back to Discord, let's copy the webhook URL, and paste it in here. So, of course, I'm deleting the webhook after recording the video, so don't try to open it. But, of course, you should be aware of whoever has access to this URL can send any message to your Discord chat. So make sure you're not exposing this. I will show you later in a second how you can include this in a secure way into your self-hosted Kestra instance. But first of all, let us just customize the payload a bit. As you can see, with those two curly brackets, you can define specific variables and access parts of the flow information, such as flow.the namespace, flow.id, and also the execution.id. Now, I don't need the execution ID, but I want to keep the flow namespace and flow ID. And here I want to add the status code that we get from our Python scripts. Okay, so first of all, I want to make this automation logic somewhat variable, that it doesn't just work for google.com, but for any website that I define. For example, a web service portal in my HomeLab. In Kestra, you can use input variables. So input variables you just define at the beginning of your workflow, and you can define any type of variable for strings, for files, for date type, JSON objects, whatever you need. For example, we can just pick a simple string here where we can store the URL for making our web request. So let's go back to the Kestra portal and let's define a new section called inputs. We want to define one input with the ID URL. You can also make this a required one, because if you don't specify URL, it wouldn't make sense to do a request. So this is a required variable, and you can also define one or more default values. For example, google.com is one of the default values that I want to define for this. And now if you want to access those input variables during the runtime of your Kestra workflow, you can just replace this here, the google.com string, use 2 curly brackets and just define inputs dot and then the ID of the variable that you have defined, in our case URL. So this is now variable. If I now save this and click on execute, you can see we can now define the URL. For example, let's test the connection to my Portainer demo interface on one of my home servers here. So let's click on execute. And it shows me those 2 tasks here. The first one is the Python script that executes the request. And the second is the Discord message. You should see the message in here. So no, this doesn't report anything meaningful. So what we have to do is we need to somehow store the status code in a variable and use this variable in the second tasks. And the way how you do this is, you probably can imagine if Kestra has something like inputs, it might also have something like outputs. And this is exactly what we're going to need. Let us take a look at the documentation of the Python task type in Kestra, because when you scroll down, you can see that each task type in Kestra also has a different set of outputs. In our case, the Python script has an exit code output that just reports the exit code of the entire flow execution. So that is what we could use. In the Python script, we could report a different type of exit code depending on the variable of the response, and then use this in a conditional statement to send a Discord message depending on the exit code variable. But what you can also do, and this is really amazing in Kestra, Kestra also has a Python specific library where you can define as many key value pairs as you want in a vars output variable. And this is where you can store any form of data from your Python script. So this is what I'm going to use. Let's go back to the source code and modify our Python script. So first of all, we need to import the Kestra specific Python libraries. So from this Kestra library, we're going to import the Kestra object with a capital K and use this to add a new output. So you just need to open the outputs function, and you can define your output variables now in a JSON object. So for example, let's create another variable called status code and set the value of this variable to the response.status code. So this should contain a 200 for OK or anything else for if there is an error. You could also add, with a comma, add multiple key values to this, but we're just gonna need the status code, so this is fine. By the way, don't forget to add this Kestra library in the pip install requirements command, so otherwise the Kestra library could not be found by the temporary runner process, of course. And now that we have this output variable, I'm just going to show you how that looks like if you execute it, so let's do a quick test here. Now to inspect those outputs, we can just go to outputs here. This contains all our output variables of the script. Again, it has the exit code that is part of the usual Kestra type, but we also have our status code that we've defined in the Python script, and this has the output 200. So this is great. We can now just access this in another step. If we go back to the flow, we could now change the content message and just start with a curly bracket, type in outputs. Now we need to add the ID of the task where to get the outputs from, in our case Python script dot vars dot status code, and then we should see the 200 as part of our Discord message. Let's quickly test this. So let's save this and do another execution. And now let's go back to Discord. Now you can see the 200. So this is really great. This is the perfect way to get inputs and outputs of those task types, especially in Python. This is really great with the Kestra library. This opens up so many possibilities to automate just anything you can do in a Python script. Really cool. Okay, so there are just 2 more things that we need to do. Store the webhook in a secret variable, and next do an if-else condition so that we only send the Discord message when the status code is not 200. So let's continue working on this automation logic. I think it's already getting pretty long, but I think this is so valuable, so I'm just going to continue finishing this here. So first of all, let me show you how to get secret variables into the open source version of Kestra. Again, the enterprise version gives you additional options. It has a built-in secret store, and you can also connect it to HashiCorp Vault and those kind of things. In the open source version, you unfortunately don't have this ability, but there's still a pretty good way to store secure secrets in the open source version of Kestra. We need to go back to the console and modify the Docker Compose file a bit, because you can add those secrets as a new environment variable in the Kestra container. It has to start with secret underscore, but then you can define anything. For example, Discord webhook colon, and then just add it as a value in here. Or what you can also do is use another environment variable, store the secret in a .env file that you protect on your server, so you can load them securely into the container. Just we've done it multiple times with any other credentials like the Postgres SQL database password and user, for example. What you have to consider is you need to store the webhook value not just as plain text, but as a base64 encoded string. We need to echo this and pipe this into base not base 500, base 64 encoded. Perfect. So now we can copy this string here, paste it in here. Okay, perfect. What you now need to do, of course, you need to take the container down, which is a bit unfortunate because you need to do it all the time when you change a secret variable. But yeah, that's it about the open source version. But I think this is still totally fine for me. So let's reload the page and then use the function secret and just use the environment variable name. You don't need the prefix secret underscore, just use the variable what comes after that, Discord webhook in our case. Do a quick test if everything works correctly. Let's click on save and execute it again. You can see I got a new message, and this is how you can store credentials, usernames, passwords in a secret variable and don't use a plain text in your workflow YAML files. Okay, cool. So now that we have all this, we need to define an if-else condition. So because we don't want to automatically send the Discord message every time with the status code, we only want to send it when the status code is not 200. So the way how you can do this is you can also layer those tasks by just adding another task, which is the ID if. So you can see there is a core task for creating an if-else condition. Enter the condition in a new property, of course. So this is where we can use basic logical condition statements. For example, we can simply just access the outputs status code variable in here and check if it is not 200. I think this is what we're going to need. And then we can define all other tasks that should only be executed if this condition matches in a then statement. So we can indent this. There's also another property for else if you want to do something different. For example, if the condition does not match, and send a simple message, everything is okay, just to the log output. You can also do the same for the Discord message. There's an error. Sending message to Discord, for example. Okay, cool. Okay, let's save this. Now everything should be okay. If we now take a look in the topology view, you can see that our workflow logic gets a bit more complicated, right? So we have a Python script here that does a simple web request, and then we have an if-else condition. If there is an error, we will send an error message to the log output and send the Discord message. Otherwise, we will just add an output. So this is where the topology gets really useful. If you have multiple tasks and if-else conditions, you can really see at a glance how your automation logic functions and what it actually does. So let's click on save and execute this. I'm really excited to see if it works. Okay, so that was log successful. So if we go to the topology, you can see that we executed the script. It took like 3.9 seconds. Then we went into the conditional statement and it was successful. Okay, so let's now execute it again, but with an address that does not work. For example, with a URL that does not exist on my traffic, so it should report something different. For example, a test host that does not exist on one of my servers. See if that works. I'm really excited to see that. Okay, so there was one error that I got, and I think this is because it is using a self-signed certificate, unrecognized name, caused by SSL error. So we need to fix our Python script quickly. So I'm just using ChatGPT to find a solution for this. Okay, so we need to add the verify false into the request so that it does not need to verify the SSL certificate. So let's try this here. And because that still did not work, let's try and catch the error in here and set the status code to something different, maybe like 0. If there is any error in the Python script. And maybe what we should also do is in the Discord message, add another variable for the host name that we tried to send the request to. So here we could just use the inputs again. Say something like request to failed with, and yeah, then it's fine. So, okay, so let's click on save. Let's run this again against something that does not exist on my server. Now you can see it was successful. If we open the topology tab, you can see it went into the different condition that sends the Discord message with an error. So in the chat, you can see monitoring alert request to blah, 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 blah failed with code 0. And now there's one last thing that we need to make this a fully fleshed out monitoring solution. We need to schedule this automation logic maybe every 30 seconds on a specific URL. So let me also show you how to schedule your automation workflows. So you can run those automation workflows in Kestra based on different types of triggers. You can use a schedule trigger, you can use another flow to trigger a different one, or you could also use webhooks so that you send a simple webhook request to the Kestra platform and then it automatically executes the workflow. So we will do a very simple thing. So we will define another trigger here. So let's go back. And at the end of the task, let's define a cron expression that runs this check every minute. And of course, we also need to set the input variables in here. So there's another property called inputs where you can define the input variables in a JSON object. So for example, set the URL to, let's define my Portainer demo 1 web interface just as a test. And let's click on save. And now, because we have added a trigger to this automation workflow, we can go to administration triggers. You can see it in here, the schedule trigger for Python test. When this was executed, you can see it already was executed a few seconds ago. So we can just go into the flows and see there was a warning here. So let's check what does that mean. You can see the warning comes from the HTTP request that was made to the certificate verifications. So I think that is totally fine. So let's try to take this container down, go into the Portainer demo project and do a Docker compose stop, for example. So then the web portal should stop responding to our request. And let's just wait and see if I get an error notification from my monitoring workflow. Okay, so here is our message. So our monitoring pipeline recognized an error with that, failed with 404, so not found. As you can see, we've just written our own monitoring script in Python and using the Kestra automation platform. This is so cool. I'm really proud of that. It actually worked because I didn't really test it before recording this video. So sometimes I'm also successful with writing my own scripts in Python, yeah. Of course, this continues reporting an error every minute, so we could also extend this Python script to store the last status in a database, retrieve the last status, and only if it's changing, sending a new message whatsoever. You can do so many more things. Of course, this was just a very, very simple test using Kestra, but I hope it gave you some great ideas on how to use this system and how to write your own custom automation workflows with this platform. I can just encourage you to experiment with that a lot. So just go through some trial and error process, try out different types of workflows, and I will definitely make a follow-up video on this, showing you some cool automation workflows that I've created for my HomeLab. Not just a simple monitoring test, but you can do so many more cool things with that. But now it's your turn, so please tell me, what do you think about the Kestra automation platform? Is this something you would consider using in your own HomeLab, and when? What exactly are you planning to do with it? I'm really excited to hear some of your ideas, and maybe I will feature them in an upcoming video. So a big thanks goes out to Kestra for supporting this video, and a big thanks goes out to everyone in the community for supporting my mission, creating free tutorial guides for you. Please don't forget to like and subscribe if you want to see more content like this. And thanks everyone for watching. I will catch you in the next video. Take care. Bye bye.